Today I'm going to talk about using Lucidworks Fusion and Solr for large-scale log analytics applications. Before getting started, though, I'd like to raise your attention to the Lucene Solar Revolution that we're hosting in Austin in October. If you've been before, then you know it's an awesome conference, and we look forward to seeing you there again this year. If not, definitely consider attending, because I think this is one of the best tech conferences I've been to, and it consistently ranks high for breadth and depth of quality content and presentation. And Ali always does an amazing job organizing it. So to cover faster log indexing with Fusion and Solr, I'm going to present a couple of key concepts, mainly around time-based partitioning scheme for log data, as well as using a thing called a Transient Collection to actually enable more high-volume indexing of logs. And then we'll also talk a little bit about schema design considerations to support log indexing and the type of queries and analytics you typically want to do. And then lastly, as Aaliyah mentioned, we'll have time to basically address any of your questions that come up during the talk or just general questions about Fusion or Solr you may have. So to get started, you can probably guess from the title of this presentation and my job title and background that it's probably going to be fairly technical. So just to make sure we're kind of clear on the motivation of, what are we trying to achieve with log analytics and the architecture and solution I'm going to present today. Most of this is really for organizations that need to index billions of log events per day in near real time. So, Solr scales very well for, just the basic architecture, very well for millions of events a day. But today we're going to really talk about a solution that addresses billions per day, much better. And the other thing is that a lot of times organizations want to analyze logs over time, So very recent, in the last couple minutes, they want to visualize that. But also, what's happening today, what happened sort of over the last couple days, maybe the last week, and sometimes even going back 30 days for deeper type analysis. And so we'll look at strategies to actually deal with those type of different time range-based analyses. The other thing that crops up quite a bit actually is the need to have dashboarding around log analytics. And I'll actually show a solution out of our Fusion product that allows you to basically very easily construct dashboards for time-oriented data like log events and visualize common questions that come up and that you want to answer, as well as allow for more ad hoc analyses. Drill into maybe something you've seen in a visualization and you want to drill in and learn more. You can use Fusion for that. And the other thing that I think is very important is a lot of the times we see with large-scale log analytics, actually see that businesses don't just need to consider the logs they have today, right? What's my scale problem today is important, but what's my scale problem going to be in 6 months as my business grows and a year down the line? And so they really want a solution that's going to be able to scale linearly with that business growth and hopefully sublinear in terms of costs. And then I think this is also important because there are a lot of solutions out there, but what's important around it today is large scale and all this big data stuff. It really needs to be easy to set up, manage, and easy to use. And there's actually a lot of people coming and going in the industry, and so you want a solution that if you have to lose an expert on your team, you just keep on running because it's an easy to manage architecture. So here we have a screenshot of a Fusion dashboard, and this actually isn't really for logs, but it shows sort of the power of the visualizations of this tool. And actually anybody who spends maybe 10 minutes working with a Fusion dashboard called Banana can really cook up a very nice dashboard, which behind the scenes is all powered by Solr queries and facets and these rich analytical features of Solr and Fusion, but make it very easy to kind of show the common questions you have about your log data over time. And so I don't want to get too much into the actual features of Fusion or how the dashboard works or any of that today. For that, I would say, go ahead and reach out. At the end of the slides, we'll have a way for you to download Fusion, or reach out to us, and we'll be happy to schedule a demo or walk you through anything you want to see. big question is, there are a lot of ways to do log analytics. There are specialized commercial offerings. Why Fusion and Solr for log analytics? For me, it comes down to 4 basic things. First, speed. I feel like Solr, obviously I work every day with Solr, and a lot of the time I spend that focusing on making it so that Solr can scale to very large indexes and very high volumes of queries and complex queries. Solr is fast, and that's why it is the most popular open source search engine, because it's fast at very large scales. The second is proven scalability. Over the last year, I have seen so many organizations basically say now they're using Solr Cloud in clusters of hundreds of nodes, as well as hundreds of billions of documents. So if you have that scale, then you're in very good company in Solr, trying to achieve those scalability levels. Because it's been done before, it's essentially a solved problem. The next thing I think that's important is community. So, of course, there are definitely specialized log analytics packages out there. However, for me, the community around Solr and around Fusion is immense, and it's so vibrant and active. For example, we just released 5.1, and I was the release manager. And I think we had something like 70 unique contributors contributing features and bug fixes just for that one release. So it's a very active community. And I think that's something that as you want to tackle larger scale problems, it's good to have a good community around the solution to learn from and share your experiences. And then lastly, I won't tread on the territory of our sales reps, but I think that our solution is very cost effective. And so I'll refer you to them, but I think this can be a very competitive and compelling offer. So before I get into the nitty-gritty details, you actually hear me speak about something called a collection. And so before I get into the nuts and bolts, I want to make sure we're all clear kind of what a collection is in Fusion and Solr Cloud. And so I'll just, off to the side there, you can see just somebody on Twitter, not one of our customers, but solar power user, 37 billion documents. I think that's fantastic. And we see that more and more every day. To me, basically a collection boils down to it's a distributed index, right? And its configuration is stored in Zookeeper, and it's managed in a single location. So if you need to add a stop word or change anything, of course you can do that in Fusion using the UI, but it's all managed in a central location in Zookeeper. A collection also has one or more shards. More and more we see the more shards versus just one shard. But this is basically your documents are distributed across n partitions of the index. And we're going to actually see today a couple of different strategies for sharding to tackle this large-scale log analytics problem. Hand in hand with shards is you have to basically come up with a way to decide which document belongs to which shard. And that's called a document routing strategy in Solr. And we'll actually talk about 2 different ways that we're going to route documents in this solution. Next, there's replication factor. So this is essentially how many copies of each document live in the cluster, right? A replication factor of 2 means you have 2 copies. If you, by chance, for whatever happens, you lose a disk, one of the copies goes away, you have a backup. And going hand in hand with replication factor is actually what's called a replica placement strategy. And we're doing some really great work. One of my colleagues, Noble, is working on Solr 6620, which is coming up with ways to have a lot more sophisticated replica placement strategy. That's how essentially collections are distributed around your cluster, so you can have rack awareness and those types of things. People typically use sharding to increase parallelism when you're indexing as well as executing queries. If you have a very complex query, it's better to basically distribute that out across a number of different shards and execute that in parallel. And then replication allows you to do load balancing because you have multiple copies of each document, allows you to route more queries across your cluster. And then fault tolerance, as I mentioned. If you happen to lose one replica, you have backups. So let's now dig into sort of the specifics of the architecture we're going to use for large-scale log indexing. The first question we really need to ask is, how are you going to organize your log data within Fusion? And probably the most obvious answer that, anybody who thought about it for a minute would probably jump to is, well, let's organize it by time, right? And that's not really a new thing. That's a popular and common way to organize data in large big data installations, Hadoop, Hive, that sort of thing, as well as just good old data warehousing. So a time-based data partitioning scheme works very well for log data for a couple reasons. First is you typically query across the date range. And so it allows you really to direct your queries to specific areas in your cluster to pull that data based on time. And the other is such as we see here, we have logs going, essentially collections for each day. And as data gets older and you don't need that data anymore, you can drop them off and add a new day as it goes on. So up at the top here, we have Fusion, basically the log analytics dashboard that I mentioned, show the screenshots before. That would be, the system administrator or customer service rep using the dashboard to dig into the log data and do whatever analysis they need to do for their job. As you can see here, basically they're querying through what we call a collection alias, right? It's called recent logs. And what a collection alias is it basically makes multiple collections look like one to your client. And that's pretty nice because, one, the Fusion dashboard, it doesn't need to know about all, the daily collections and however many they are in recent logs. If you change requirements, the dashboard doesn't need to know about it. The other nice thing is, as data ages and you drop older daily collections out and then bring new ones in, that all changes behind the scenes, again, not affecting your dashboard. So it makes it very isolating details between different components in your architecture. Okay, then below the daily collections, we actually see we have shards. And those shards, in this case, in this architecture, are actually organized by hour. So, zero-based index from hour 00 on up to 23. So every shard holds an hour's worth of data in each daily collection. Some of the benefits of this approach I've kind of mentioned, but first is most of your log data, especially the high volume, big scale stuff we're talking about here, is like write once and then read many times, right? So think about, you index a log event once and then it's used in potentially hundreds of queries and analytics before it ages out, right? And so this idea of time-based partitioning works very well for that type of data. The other benefit is that a lot of the times your queries are structured around time ranges, and so when you're querying, and especially around like recent time ranges, and so when you query into Solr, a lot of the work that Solr does to execute a query becomes cached and stays hot in the cache and stays hot in the OS cache. Behind the scene, at the Lucene layer, Lucene takes advantage of the OS cache by reading a lot of the big data structures that live on disk and holding them in cache if they're used frequently, right? And so this strategy of laying out data across time really helps improve query performance. And to kind of give just a little bit of sort of anecdotal evidence behind that. So we recently worked on a POC where we implemented this architecture for a customer that needed like 4 billion docs per day, 130-some billion docs per month. And the idea here was that essentially they would have Fusion dashboards come up and hit this data, and they were faceting on result sets that had billions of results, right? And all of this performed much better, and we would actually be able to load a dashboard, in a number of seconds, whereas previously the previous solution actually took minutes to show similar type of analytics. So again, that goes back to Solr being very fast, and the way Solr is very fast is the way it keeps these expensive data structures in cache. The other thing is, and this kind of falls in with, again, how dashboards work, they typically send a flood of queries that all have the same basic time range filter into the search engine. Well, that gets cached, and the nice thing is that you can actually do very smart things with the routing of those queries so that you're only hitting the specific shards that you need to answer the query, right? And so if I want to visualize some activity over the past 2 hours, then I really only need to hit those 2 shards. Again, since we're not changing data once it's written, that performs very, very quickly for most reads. And then the other one that I think, and this is more ops, but this is important because a lot of doing this big data stuff is you have to consider what is the impact to your operations. And as you scale out, again, as your business grows and you have more logs to deal with, you're not going to grow out of this architecture because you just add more nodes, right? There's no shard splitting, there's no rebalancing, there's no reindexing, there's none of that because an hour is an hour. The worst you might have to do is switch over to a half an hour base shard, right? Which you wouldn't have to change any old data. You would just, as your data grew, you would switch to a smaller time scale of sharding. But so the ops and the management of this type of sharding scheme is actually very easy. But of course, there's always a but, right? So there are some limitations to this, and the most obvious one is that your log indexers, let's think about the applications, and I won't have time to get into the log indexing applications on this call, but you can think about out of the box, Fusion provides a log stash connector, right? So that's a very common way to process and index logs in the Solr. It's very easy, and it comes right out of the box. So, but there's also Flume and these other tools, okay? So, and that really depends on what you already have in your organization. But the log indexing application is pretty much sending logs in for current time or near real time. So you're really always just indexing into the current bucket, if you will, the current hour shard. Well, I'm sorry to say that a single hourly shard cannot keep up with high volume writes. I do a lot of work in this area around Solr Cloud and benchmarking and things, and 15 to 20,000 docs per second per shard with replication is normal and maybe actually even a little better than normal, right? So if you got that without doing much tuning on decent hardware, that would be good, and that's about all you can get. The problem is if you're doing billions a day, first, on average, that's like 40 to 50,000 docs per second, if you're doing 40 billion per day. But the problem is you don't typically have a uniform distribution of traffic, of logs, on every hour is not the same. And so, in the proof of concept that I mentioned, they kind of asked us, they would be comfortable if they felt like, it was no big deal to scale up to 120,000 writes per second under peak load. And so, again, you're not going to get there from here if you're just doing a single hourly shard. The other problem is that even if you are, you only need the 20K per second, that shard is going to be so sort of under pressure because of the indexing that sending queries into that shard, the query performance would suffer greatly. And so then it gets back to you're not really meeting the needs of your users. And then lastly, and I think, again, I just keep coming back to this because, the devil's always in the details with this type of stuff. And it really makes sense when you're designing an architecture to kind of keep the details of a lot of the complexity behind how you're partitioning your data, and that keep that hidden from, in this case, your indexing applications or your dashboards and things like that. So it's really, one of the tenets of good architecting is kind of separation concerns and hiding details between components, and this fits right in with that. So we'll now propose time-based data partitioning, but we're going to introduce this idea of a transient collection for indexing, right? And so you can imagine, and I'm focusing here on the right of the screen, we have our log indexing app, and that could be Logstash or Flume or whatever else is out there. There are a number of them. And notice that it's actually logging through a collection alias again. Okay, and this shows again the power of collection aliases, because the Logstash app in this case, it just knows I'm logging current logs. What you do with those on the back end is your business. I'm just sending current logs to the current log alias. Okay, behind the scenes at the Solr layer, we have what's called the transient collections. And then for this example, you can see I'm basically logging into the hour 23 of February 26th. Okay, and notice that instead of hourly shards for this transient collection, it just has 4 shards. Okay, and it doesn't have to be 4 shards. It could be 40 shards. You know, the number of shards in the transient collection depends on, again, your write volume needs. Okay. And so briefly, I won't spend a lot of time in this diagram, but this is essentially how Solr Cloud really performs well for indexing. And so you can imagine an indexing client sending a batch of documents into this smart client, which is now called Cloud Solr Client, not Cloud Solr Server, to be a little bit more intuitive. What that does is it actually has the ability to go into Zookeeper, understand the topology of your collection, and know which node is hosting the leader for every shard. And then it can directly route documents to those shard leaders. If you're processing a batch, it can basically break the batch up and route sub-batches to each shard leader in parallel. And this scales very, very well. Okay? And so this is the strategy we're actually going to use for the transient collection. So, sorry, before I move past that, the other thing I wanted to mention about the transient collection is that effectively every time you roll over to a new hour, you have to have a new transient collection that you start writing into. And that's essentially, I'll have a slide that digs into how we do that. But the only other kind of tricky thing I think here is to notice back on this diagram, the recent logs. Again, that's what our Fusion app, for example, the Fusion dashboard, is sending queries to. So notice recent logs is hitting the 25th and it's hitting the 26th, but it also needs to hit the transient collection. And that's so that the recent logs can actually get access to, you know, in near real time, the data. But the nice thing is since the transient collection has any number of shards you want it to have to support your write throughput, those queries that need to hit the near real-time data coming through recent logs, those queries will still be very performant because each shard, the theory here is that each shard is not being taxed or overtaxed by the indexing throughput because we've distributed out that load across any number of shards. I'm just showing 4 here. It can be any number. So the idea here is that your queries coming through the dashboard hit this, and they'll still be performant enough to address the real-time needs. Right? And the H23 shard is grayed out, and I'll get into why that is in a second. And then, so in the POC that I mentioned, we actually did achieve 120 kDocs per second with replication in a cluster with 20 servers. And I believe we actually used 40 shards for that. And the reason was because we actually really wanted to support a lot of complex near real-time searches at the same time we were doing that indexing. So again, the beauty of this transient collection is that it just uses built-in, you know, hash-based routing, built into Solr Cloud, and you can scale it up to meet your peak write without suffering any of the problems at the time-based single shard thing that I mentioned. So okay, I talked to that slide. So now we have effectively 2 strategies, right? We have the time-based daily collections, the 25th, the 26th, and onwards, and those are sharded by hour, right? And that is really good for our read performance and optimizing reads and keeping things hot in the cache, as I discussed. And then we have the alias, the transient collection approach, which allows us to scale the writes as much. The problem is we have to have a way to go essentially from the transient collection into the hour collection when we roll over. So let's look at actually how that would work. So imagine now I was indexing into February 26, hour 23. Now imagine we have a log event coming in from our logging apps that rolls over to the next day, right? We've hit midnight on the 27th. And so now what has to happen, right? Well, we don't want to send those log events into Feb 26, H23. That'll make your data really sort of messy. You don't want to do that. So the first thing we need to do is we need to redirect rights to a new transient collection, okay, Feb 27, H00. And this, again, shows the power of that collection alias. So the log stash, it doesn't know, but behind the scenes, we were able to switch, and I'll talk about how that switch happens in a few slides, but we were able to switch over the transient collection unbeknownst to your indexing application. The next thing that needs to happen is we need to tell recent logs, the collection alias, about it. Otherwise, you're, again, not pulling in the most recent data. So, again, recent logs is how we're reading this near real-time data. It needs to now know about the new data coming in on this new transient collection. Again, using the collection alias makes that very easy. It's very easy to add a new any new collection into a collection alias. And again, I didn't say this before, but collection aliases are a very nice feature built into Solr Cloud and Fusion. Okay, so now let's turn our attention to the old transient collection, H23. So what do we have to do there? We have to get the data that's in that collection migrated over to the actual, the logs 26, hour 23 shard, okay? Because we don't want to keep this transient collection around. Again, maybe it has 40 shards, and there's really no reason, since we're not going to be updating into that collection anymore. What we want to do is we want to collapse all those shards down into a single hourly shard, okay? And again, if you're doing 4 billion a day, again, probably not a uniform distribution, but that's around 170 million per hour. Maybe a few have double that or whatever, but those are sort of a modern hardware, and Solr handles 200 million documents, 300 million documents in the single shard very well, right? So you're not going to be having too much problem, but if you do, you can also have a half-hour time split between your shards if you need to, if your data is that big. But the idea is we need to take from this 26 H23 collection and collapse all those shards. The beauty here is that Solr and Lucene under the covers support what's called a merge. And so it allows you to take multiple indexes, or however many you have, and merge them into a single index and build up this H23 shard. And so behind the scenes, as things are happening, we are basically going to merge all those shards into this H23 shard. And notice that the recent logs is still servicing query out of that transient collection, the H23. It's because the hourly shard that we're merging into, that we're creating, isn't online yet. So we have to still be able to serve queries if any of the time ranges cover that time range. We still need to serve them out of the transient collection. Okay, so now we're going to activate H23. And so now it's purple. It's essentially activated. And then the first thing we have to do after activating that, or around the same time, there's some timing issues in there that I'll address. But essentially, we want to stop sending queries through the recent log alias to the transient, and we want to send them now to the newly minted H23 shard, right? And once queries start hitting that shard, again, it'll pull data up into the OS cache off of disk, warm up the caches and Solr and all this kind of good things that really help query performance. And then lastly, we just, behind the scenes, delete the transient collection. One thing I want to mention here is that it may seem like there's some timing issues, but in reality, the way this works, and this is all very scriptable, very, very straightforward to implement, is that you don't really, like the merge doesn't have to happen instantly and things like that. So because you do have to move data, across your network and things like that, so you can throttle that so you don't swamp your network and those type of things, because this whole merge step and creating the H23 shard, it really doesn't have to happen instantly, right? It can happen in the background over the course of a couple minutes. For doing hourly shards, you obviously don't want that process to take more than an hour, because then you'd constantly be getting backlogged. But I think you see the idea there. So let's get into the nuts and bolts, how to effectively implement this type of solution. And the good news there is that most of the features are provided right out of the box with Fusion, and Solr under the covers. So I already mentioned that we have a number of great connectors, Logstash included. That's a really good way to get started with indexing your logs. And as I mentioned, we're hiding all the complexity of this partitioning and whatnot behind the collection aliases. So Logstash comes with, basically you can just send docs into Solr and then they end up in the right place using the alias. Banana Dashboard I mentioned. Obviously behind all of this is Solr Cloud. I'll mention Solr Scale Toolkit because I actually use that on the POC, and the reason I think it's important is because we're actually able to spin up a 40-node Solr Cloud cluster supporting probably a 4 or 5 node Fusion node cluster to support this in about an hour. So we had logs flowing into this large scale cluster, in about an hour, maybe 2, once we got everything sorted out and all the monitoring set up and whatnot. So that's pretty impressive that you can set up this type of architecture, very quickly using the tool set that's already out there. And then Fusion comes with collection management and monitoring and security and all those nice enterprisey things that we need when we're talking about doing, an enterprise rollout of this type of solution. What's not provided are a couple of things that I showed in the slide. The main two obviously being the rollover from one transient collection to the other one. I showed that in the slides where we rolled over to February 27th, midnight, the new transient collection. So one of, I think, the powerful things about Solr, it is a very mature technology, and because of that, there are a lot of ways to extend and plug into Solr. And so to implement the rollover aspect of this, I actually used a way to plug into Solr, plug into the actual how update requests are processed. Okay? And so the custom update request processor that I plugged into Solr essentially sees when we roll over to a new hour and knows it needs to basically reroute those docs to the new transient collection, create it if needed. I actually do some look ahead and create a few transient collections out in the future, so you don't have to wait for those to get created and that type of thing. It also, as I mentioned, it updates the collection aliases for reads and writes, so that basically this new transient collection is included, and that sort of thing. And the nice thing is, and again, this goes back to and speaks to the power of the Solr Cloud architecture, is that it's based on Zookeeper. It's based on a proven cluster coordination technology. And so think of this. You have all your indexing apps sending logs in, just flooding logs in. It's highly probable that many nodes at one time are going to see that switch over to midnight on February 27th and want to do all this stuff, each one. And so I use behind-the-scenes Zookeeper to coordinate some of those basically things that have to happen once in the cluster, and then things need a block until that happens and they can write to the new collection alias and all that good stuff. But the point is, we have Zookeeper behind the scenes to actually help coordinate all of that. And that makes, again, going back to the architecture being actually very simple to understand as well as manage. And then lastly, this is there's another piece that isn't quite productized yet, but it's a custom Python script, and its job is to do this merging of the transient collection shards into a single hourly shard. Because there's actually a number of steps that go on there. And the first one is you have for the transient collection, you have shards distributed around your cluster. The idea there is, again, we were scaling right, so we want to distribute the shards onto a number of machines. Well, those all have to be pulled down onto the single, onto a single machine, and for the merge to be able to happen. Okay, so you do need some extra disk and things like that. So there's some ops stuff that's involved with this that I won't probably get into. It's not as interesting for most folks, but you could pull those shards down onto that single host. Out of the box, it just uses SCP-L, right? You can set essentially a throttle on the secure copy. You can set that limit, and so you can throttle. And that, again, that's going back to the point that this merge doesn't happen instantly. That it'll happen as soon as it happens. And so you can throttle and not saturate your network and those type of things because, again, you're always indexing and you're always executing complex queries and things like that. So you can really throttle the network. It then does the merge, and then the next thing it has to do is actually has to activate that new hourly shard. In the diagram, it was H23. And to do that, basically, Solr comes with a create shard method as part of the collections API. And you just say create shard, and you point, you basically tell the collection, the thing that creates the new shard, the host where you did the merge on, and it figures it out and loads that new. And then obviously you have to remove the transient reference from the read alias, right? So that basically our recent logs isn't hitting both places. And then obviously, after you've done that, you can actually start to add replicas for that new hourly shard. If you want to have multiple replicas, which in most cases you probably do, you would add replicas once it's active. And that, again, happens behind the scenes using built-in Solr replication, which can also be throttled. Okay, so I won't spend a lot of time on this because I think it's fairly obvious, but it was something that in this POC and kind of in our thinking that it didn't jump out right out of us when we were first architecting. But a good strategy here really is, put your money into kind of SSDs and a lot of RAM and that kind of stuff for your recent data. And then older data, as data ages, it's less valuable in most cases. You can kind of migrate that out to what I've heard people call, the old platter disks, spinning rust. So, and this again goes back to this being a very cost-effective and competitive solution in the sense that you can very easily, this is not something that's hard. Again, you have to kind of think about the throttling and not saturate your networks, but moving data off of SSDs and onto slower disks is a very good way to save costs and keep data around when you do need to query it. And then again, obviously, query performance will go down a little bit, but that's usually acceptable as data ages, right? Most people get that. A couple of things to call out there. Effectively, you can just, if you need to move data, you can effectively just use the Solr API and add a replica, and Solr will start replicating the index out to, or replicating the shard out to that new replica. That's presumably out on spinning rust. And the nice thing is that with Solr 5, you can actually throttle, again, the replication transfer speed, so you can control that. Very nice thing. Or, again, a lot of people just like tools, tried and true tools like SCP, and you can essentially limit how quickly SCP does that type of thing. Okay, so that's kind of the architecture that we came up with. The second to last thing I want to talk about is schema design. And the main point I want to make about schema design in all of this is you actually have to do it. There's, schema lists get thrown around a lot. Well, the fact of the matter is there's always a schema. It just may not be a very efficient one, right? And usually Solr has built in, and it's an awesome feature for prototyping and getting data in quickly. If you haven't seen Grant's presentation about city bike data and how he just throws CSV downloaded off the web into Solr and immediately is able to do these crazy analytics on it, that's impressive and that's awesome. But if you're going to do really large scale, and again, we're talking terabytes, potentially terabytes per day of data with replication, then you have to really kind of take a step back and say, okay, now we prototype this. How can we squeeze every little byte out of our schema and every bit of efficiency out of our queries? And that comes down to schema design. And a couple of things shook out of our POC and our research in this area. And the first one was like, at large scale, SSDs and memory, they're still expensive, right? Like some of the high-end hardware out there is surprisingly very expensive. And so, you want to do a good job at like utilizing that and using that for the most recent, most important queries, and then use cheaper stuff for older data. And then, obviously, even if your recent data is big enough, you'll have to have enough SSDs to store it on disk. So you want to kind of design your schema so that it's as compact as possible. Now, with logs, a lot of times the guys designing and setting all this up, they don't really control the format of every log, right? Like it's a little wild west of what logs are going in there. And so there is this trade-off and balance between flexibility and letting any team just, throw logs in however they want, and then, achieving peak performance and efficiency. So I think there's always has to be kind of a give and take where when you're doing schema design, you want to be flexible, but at the same time, you do kind of want to wrangle them in and, have some standards around which fields will give them best performance and to use and that kind of thing. You don't want to have, for example, a highly efficient doc values field, called user ID that you maybe do a lot of sorting on, and then have some other group come in and call it like, user ID with a underbar between the user and ID, because then now you have basically the same field, but one's optimized in Lucene and the other one isn't. The other thing we found is actually with log data, typically you're usually doing more structured queries, and it's kind of it's rare for first off to have an ID, a unique ID for a log entry. You can basically create one. You can synthesize one from like the host name and the application and maybe the line number of the log. What we found is actually it's better to just go ahead and use like surrogate keys, like a UUID. And there's been some research done by Mike McCandless. He's one of the Lucene committers. And what's the fast unique ID to use? And we found that using kind of the UUID version 1, which there's a Java implementation out there. So if you're doing this, this would be a good thing to look at. The licensing around that prevents us from actually shipping that with Solr, but you could definitely use it in your app. The other one is, and this gets back to the whole idea of query performance and be able to drive these dashboards off of very large result sets, is to use doc values. And doc values I'll talk about on the next slide. And then also this is pretty basic, but you do a lot of range queries across dates in these type of solutions, and so you want to use the built-in stuff into Solr that allows you to do very efficient range queries. I almost bring this up because I didn't do that in the original query I did for our POC and ended up having to re-index like billions of docs to fix that problem. So again, it's something you want to plan for ahead. So just quickly, a little running over on time, but I want to leave plenty of time for questions. Doc values, if you haven't been introduced, basically doc values are for fields that you really need to do fast sorting and faceting on, right? And those are there's probably a handful of fields for every log that you want to kind of do that. So definitely recommend using doc values for the fields that are really important for driving your analytics. Essentially, doc values are more of a column-oriented view of a field in a Solr index. It's sort of an inverted, uninverted view of a field, and which makes it very fast to sort. I like this quote actually from Robert Muir. He's a long-time Lucene Solr committer. I dug this up out of Jira. 5761. Basically, I was doing some research on, like, how do doc values deal with the disk and things like that. And so pretty much, they've tuned everything about the default implementation of doc values to keep it all on disk but still be fast. And what that does is it really helps kind of reduce pressure on your Java garbage collector. I won't spend a lot of time on this. I put these in here because it was a good lesson learned. So we are trying to do very, very complex queries, hitting Solr with billions of documents. You're going to run into GC tuning, okay? That's just the bottom line. And what we actually found, we had really good success with setting the max heap to 32 gig, which is huge. But most modern servers have that much memory. But the lesson learned there is that you have to tune a few things because otherwise you end up with these really long pauses that you don't want. And as I mentioned here, really long pauses in Solr Cloud are bad because they basically cause the Zookeeper session to get expired. And then that looks like the node is down to Zookeeper, and it can trigger leader elections, and a lot of really bad things can go on. The cluster will heal itself, but it's not a good thing to drop a session, especially due to GC pauses. So these are the flags we used, and feel free to disregard this, but basically with the big heap there, we ended up setting the new ratio, which is the size of young objects in the heap, to be much smaller, and that's what that new ratio 5 means. And that actually ended up being very good, and we only had very small pauses and few pauses, even driving extremely complex queries across billions of result sets. So with that, I want to thank you for your time today. I hope you had some fun. This was definitely a fun architecture to put together, and I had a lot of help from my colleagues at Lucidworks putting this together. And so, if you're interested in Fusion, definitely download it or reach out to us, and we'd love to work with you on log analytics. So with that, I'll turn it over to questions.
Great, thanks, Tim.
You're welcome.
Yep, so we do have some time for questions. We will now enter the Q&A portion. Again, if we do not get to your question today, someone from Lucidworks will reach out to you directly. So the first question we have for you, Tim, is you mentioned using SSDs for faster input-output throughput. Would HDFS help in some of these cases?
I don't know the benchmarks between the two, but writing to HDFS is going to be subpar to SSDs, local SSDs. You're not always guaranteed data locality, first off, and then especially the reading. The HDFS solution relies on HDFS block cache, which just isn't as good as the OS cache being. So I think the message I've always had, and I think I still agree with this, is that HDFS, storing indexes in HDFS is a really good solution for operational efficiency and kind of economies of scale. You've gone out and invested a large sum of money and time and resources into setting up your HDFS cluster, then I think it makes sense to use it, and you can definitely point Solr at HDFS to store your indexes. So if you're seeking that kind of ROI on your HDFS investment and operational efficiency in that, you can do that, but SSDs will actually still be superior in terms of performance.
Thank you. Next question. How would I implement alerts or saved searches in Fusion or Solr?
Sure. So I believe I can't speak to the roadmap. I use the Fusion roadmap. I'm a lowly engineer, but that's a good question for maybe a sales rep or whatever. But I know it's on the roadmap, and actually for the POC that I mentioned, we did some things around alerting and that kind of thing. So if it's not out yet, it's coming. quite soon. So, that's definitely a planned feature for Fusion.
Great. Can index files be compressed on disk and still be accessible through search?
So I think the easy answer there is, and I don't, I'm not up on my hardware compression and all those things, but I mean, if it's something at the system level, for sure, right? It's almost kind of like system level encryption, but you can't just like zip up a directory and then point Lucene at it. I will say, however, though, that Lucene Index, which is obviously the technology behind Solr and Fusion, is already a highly optimized, compressed data structure, for lack of a term, right? So I don't know how much compression you would actually get beyond that. Now, there is storage, right? Like if your log messages are big and you need to store those as a stored field to retrieve the full message, there are different codecs in Lucene that allow you to have different types of compression and things like that. And you could even implement your own to do that type of thing. If your messages are like JSON and they're structured, you can actually you can do tricks such as just indexing the data aspect of the JSON and then kind of rehydrating the full JSON structure on the way out using like a document transformer in Solr. So there's a lot of tricks you can do to kind of save space on the index side. But I'd say just in general, it's already a highly optimized and compressed data structure to begin with. So like compressing it even more, I wouldn't guess you would get that much bang for your buck.
Thank you. If you recommend 32 gigabytes for Java heap size, what do you recommend for physical memory on the node?
Yeah. So I guess I was pretty lucky on this project in that they had like 128 gigs per node. What it really comes down to are your SLAs around query performance and how big your index is on disk. Now, taking a step back, so your size of your index on disk isn't like, you can't say it's 100 meg on disk. 100 gig on disk. I need 100 gig of memory, because not all of those data structures that are stored on disk really need to be kind of hot and loaded in, especially SSDs. It's really like these big kind of important data structures in the index, postings list, that type of stuff. Those will get loaded into your OS cache using mmap, right? And that's a technology that Lucene uses to effectively keep these big data structures out of the Java heap. So if I was doing 32 gigs, the reason for that is, again, I have gobs and gobs of data, so I would say somewhere around 96 to 128 gig of RAM would be ideal.
Thank you. We have logs for both users' front-end activities as well as general machine and server logs. Are both of these valid use cases for log scale analytics in Fusion?
Yeah, I would say absolutely. You would probably have different dashboards, right? And I didn't really get into this, but you could have different collections and different dashboards, that basically drive the different business requirements and the different users. And it's very easy to create a new dashboard and that kind of thing. So yeah, I think either of those use cases are very applicable. And then what we saw and talked about here, I think, is again great if you just have really huge scale and are planning to keep growing and growing and growing.
Okay. Can we mark collections or shards as read-only? Would this help performance?
I would say the architecture that I kind of walked through, the whole idea of using the transient collection for write, and then all of the other, the historical data, be it last hour or last week or 30 days ago, all of that is effectively read-only. because you're not actively writing into it. So there aren't commits happening. So behind the scenes, Solr has a searcher. The searchers all stay open and hot. Caches don't basically get invalidated, because when you're doing indexing and you're doing near real-time indexing, you're doing what's called soft commits. And soft commits, by their very nature, any kind of commit by its nature, has to actually flush the caches. Because data has changed, the caches actually have to be invalidated. But since we're not actively writing into the hourly shards that we've already minted, is the term I like to use, they are effectively read-only. Another thing you can do as part of that merging process that I described when I was minting that H23 shard, you could actually run like a minor Lucene optimization on that. There's a lot of disagreement on whether optimize works, but in this case I think it's very valid because, one, it's a background process. You're not actively hitting it with queries at the time while you're building it. And so once it's built, you can actually run an optimize, and you don't have to optimize down to one segment, but you can optimize maybe down to 10 segments, and that will make searches a lot more efficient. So I think what I presented here is definitely pretty much the bulk of your historical data, or all of your historical data is read-only, and the only data that's actually being actively indexed is that current hourly shard.
Thank you. You mentioned in the slides about migrating old data to spinning Rust after use. Is it best to distribute an index to spinning Rust at the time of indexing, or migrating at a later date?
So this question came up, and I've seen organizations do both. I think I kind of lean towards the later date because the problem is, and again, you could come up with like a Kafka queue or something in the middle, but the problem is the whole reason behind the transient collection is that the write volume is so high that you can't write into a single shard and keep up. So if you had a way to actually write into two different places, you could do that, but I kind of like the idea of actually moving it down the road, whatever down the road means for your application and for your organization, but moving it and then using, again, the built-in tools into Solr, the replication throttling or just SEP throttling to kind of make sure that's not this huge burden. I mean, it's always going to be some level of resources on your network and your disk, but you can kind of throttle that to slow it down and not cause real problems in your network. So I kind of like the down the road, doing it maybe in maintenance windows and those kind of things that you can have more control over versus in real time or anything like that. And it also kind of complicates, if you think about it, it complicates the indexing architecture, because what if one goes down? What do you do then, right? And so it's kind of easier just to write into one place and then move it as you need, sometime in the future.
Great. So this will actually be our last question. You reference using Flume or Logstash for log ingestion. Would a project like Spark be applicable for log analysis on Solr or HDFS?
Oh, absolutely. So that's a question near and dear to my heart, because I also maintain our kind of Solr Spark integration project. And Spark's actually a great technology for this. It integrates nicely with technologies like Kafka, where you can basically just send logs in a flood to a Kafka topic and then process them with Spark streaming, and that would allow you to do all kind of enrichments and things like that. Spark is also very, very awesome at reading data in HDFS at high performance. So definitely you can use Spark, and take a look if you haven't looked at the Spark Solr integration project. And sort of exciting news coming up is a future release of Fusion will actually include Spark for doing a lot of the powerful things that we do in Fusion, such as recommendations and aggregations and those type of things. So yeah, I absolutely think Spark is a great technology that fits right in with this very well.
Great. So we are out of time. Thank you, Tim. And again, thank you everyone for joining us today. Everyone who registered for this webinar will receive a link to the recording shortly. And if we did not have time to get to your question today, please look out for a note from someone on the Lucidworks team. Thanks again, and we hope you enjoyed the webinar.